Okay, so here's the overview for today. I have a few words I want to say about software engineering. Then I want to discuss, there's a discussion on Softmax that came up in context of the lesson 10 video, and I thought it's a good thing, it's an interesting thing to go over, so I think I'll go over that a little bit. Then I'll plan to go through the notebooks, all the 05 notebooks. That's kind of ambitious. We might not make it through, but I've annotated all those notebooks, and if we don't get through them, you can always go through them yourself on Colab. They're on the Git repository that I put up, and I refreshed it this morning. The stopping point for this lecture will be at 1 hour and 40 seconds in the lesson 10 video. That's where he just begins to go into convolutional neural networks. And so we're going to stop right at that point, and we'll take up there next week. Okay, so here is, I've got to reorganize things a little bit. I want to put this here. All right, so I have a few words to say about software engineering because they do make an important point that they're trying to teach a little bit of software engineering in this class. So I've got a few points that I wanted to make. This is not all of software engineering, it's just the preliminaries. So, but I thought they're interesting points anyway. So the first thing, I have 3 rules that I usually follow in my software engineering, and I thought I'd share them with you. The first one is use descriptive variable names. It's a little bit of extra effort, but it's worth it. So for example, instead of variable names n and m, which I'll have something more to say about later, use more informative names such as n rows or n columns, so you'll know what you're talking about when you read the code, and so other people will too. Instead of something like nh, use n_hidden instead of, so that you'll know what that nh stands for. Nh is kind of cryptic, and it's hard for somebody who's reading a code to understand, even if they're familiar with what we're trying to do in the code. Instead of c, which is another single variable name, use nout, which is a more descriptive name. My rule is never use single character names for important variables, and the rule is, for me, something that I learned I learned the hard way. I mean, if you use a variable n throughout your code, and then you want to re-engineer your code, and you want to change the name or do something or figure out what happened, figure out all the places where you used n, that variable, you can try doing a search for it, and good luck, because n is one of the most common letters in the English language, and it's going to turn up everything but the kitchen sink. You're going to have a hard time searching for the instances of the variable that you're trying to find. So instead of n, you could use something more descriptive, such as n_iter, so that you can easily search for it. All right, next page, and then a couple more notes. Oops, that's not what I wanted. Somehow. All right, Okay, the second rule is that's helpful is when you're calling a function and you're calling it and it takes a numerical input, such as 10 or 100 or some integer, pass a numerical value in using a keyword argument. So, for example, here's an example. You're calling some function sampler, and you see the list of inputs, and there's this input 3 that appears there, and there's another input false. And when somebody's reading that code, they have no idea what these inputs represent. So a better way to do that, or I'll just say an alternative way, is to name the keyword. To use a named argument there, and instead of calling the input out as a 3, call it out as batch size equals 3. Instead of calling the input as false, call it out as shuffle equals false. Then when you're reading the code, you can understand exactly what these variables are doing and how they control the execution, how they control the behavior of the function that you're calling. And the third thing is document your code as you write. It's much faster to write code without documenting, and a lot of people don't want to spend time documenting their code because it really does slow you down a bit. But it pays off because when you come back to that code, you'll understand, you'll have a chance to understand and remember what you did. I mean, some people are, they have eidetic memories for stuff like this. And like I remember a guy, I was taking a physics class once, and this one guy would sit there and he would never take notes. And I would ask him, well, why don't you take notes? And he says, I don't need to because I can remember everything that was said in every lecture, so I don't need to take notes. Well, if you're like that, you don't have to document even for yourself, but you do have to document for other people because other people aren't like that. They need to know what's going on in your code. They need to know how you built the code and what you were thinking when you wrote each block so that if they want to vary the code or if they want to change it, they can understand your line of thinking. And also, it will help them to find errors in your code. Because if you write a note about a block of code and saying, I was trying to do this, and here's what I did, and then somebody can read that and say, nope, he or she didn't do that right. It's incorrect, and it'll help you to spot. It'll help you and other people to spot errors in your code. So these rules are, you learn them as you go, and I may be preaching to the choir. I don't know how many. Some of you might have a lot of experience with software engineering, and then you'll know. But if you're new to software engineering, these are good rules to start with. Are there any comments or questions? Again, I like to know that I'm not talking to the wall. So if anybody has any comments or questions, I'd be glad to, just speak up.
Hi, Joseph. This is Philip here. I just wanted to mirror your points. I think they're excellent. I would also say it in the same way. So yeah, I don't have anything to add, but that I can support your points that you've just mentioned.
Thanks, Philip. I recognize your voice.
Yeah.
All right. Okay, next. Oops. Okay, in this lesson, there came up a discussion of the Softmax, and I thought it was an interesting discussion. So I'm going to remind you of the Softmax definition. This is taken from one of the previous notebooks that we've already covered, but just remind you what the Softmax looks like. It's basically you take a bunch of weights and you exponentiate the weight and then divide it by the sum of all the exponentiated weights. That's the Softmax. So each weight can be transformed to a Softmax weight. And what it is, it's basically an exponentiated weight that's normalized by the sum of all the other exponentiated weights. Okay, and then there is a simple formula to compute it by here, implementing it in code. And as Jeremy explained to us, we generally don't use the Softmax as is. We take the log of it in order to be able to deal with small numbers. So that's just to remind you what it looks like. And then there's a discussion. I'm going to go to that now. So in the lesson 10 lecture, starting at, I forget which point, somewhere around 40, I think somewhere around 45 minutes. I've written it somewhere. You can find where he starts talking about the Softmax. And let's see. I'm wondering if I missed the, let's see now. Yeah, this is it. I got my slides messed, order of my slides messed up. So this is the slide I want to be on. Yeah, so there it is. It's 44 minutes and 30 seconds in lesson 10. He talks for about, I don't know, 8 minutes about this. And he's discussing this example that he has, the spreadsheet that he has. And in the course of this discussion, he makes some really good points, and that is that it's possible to use Softmax in an incorrect way, because Softmax operates under the assumption that each data point, you're in a multiple class problem, and each data point corresponds to exactly one of the classes. So that there's two kinds of problems that don't fit this. One is where data points can belong to classes that you don't know about or that you haven't represented in your data. And so now your class representation is incomplete. That would violate the assumption of softmax, because the normalization assumes that when you normalize softmax, you assume that you know all the possible classes. And the second kind of problem is where each example can belong to more than one class. And then that also violates the assumption that each data point belongs to exactly one of the classes. So these are the two kinds of problems: the multi-class, multi-label problems, and missing label problems, where the identified classes aren't complete. For these types of problems, you know, softmax is not guaranteed to work. And Jeremy shows that for problems like this, there's a better approach, and that is to create a binary classifier for each of the classes, that will be the method of choice. So back here, this is the example that Jeremy's working with, and I thought, oh well, I thought I'd annotated this slide. I mean, I thought I had drawn on it, but I guess not. Let me see. Yep. Somehow it didn't work. Anyway, so this is a problem. This is a spreadsheet that Jeremy made called entropy_examples, and it's about a contrived example where you have where you're trying to classify, you know, cats, dogs, planes, fishes, and buildings, and you have two images, and you have weights from one of the pixels from two of the images, and one of the columns, this is the weights of the pixels, the output column, and then for image 2, the weights are in this column. And you'll notice that there's actually there's just an offset difference between these two columns, so that one of them is different than from the other one by 1.44. And in this case, it's kind of interesting that the softmax weights become exactly the same. And so, you know, you have two different images, and the pixel values are different, and yet the softmaxes are the same. And they seem to suggest, when you go down the softmax column, it seems to suggest, oh, this looks like a fish, mostly like a fish, and this one also says it looks mostly like a fish. Jeremy says that maybe you have one of those two cases going on. Maybe maybe this is really a multi-label problem, so that things can have more than one thing in them. So this image might have a fish and a building in it, you know, or a dog and a cat in it, so on. And if you want to allow for that possibility, the better idea is to use binary classifiers for each of the, you know, for each class. And so when you do that, you get these weights. And there's a little mistake here. He says binomial, and he really means binary. Actually, yeah. Anyway, he really means binary. So this binomial is a mistake here. It shouldn't be. It's a binary classifier that he's trying to illustrate here. And notice here that the results are different. The two images give different results. Now, one says, oh, it looks like it has a fish in it and a building, and maybe even a cat. And this one says, no, it just looks like it has a fish in it. No, if the cutoff is 0.5, right? If the cutoff is a weight of an activation of 0.5 or a weight of 0.5, then the second image, you say it has a fish in it and pretty much nothing else. The first image has signs that it has a cat, a fish, and a building. So that's the difference. By building the binary classifier for each class, you now allow for the possibility that there might be more than one class going on. All right. I have a little bit more discussion about this, but I think I'll skip that. You can look at it at your leisure later on. I have a couple more slides on this. So anyway, are there questions up till this point? Because if not, I'll move to the notebooks that we want to cover. All right, we covered the callback, 04 callbacks. We covered most of it last time. I'm going to assume that people actually read it and finished it that way. So are there any questions before I start? Are there any questions on the 04 callback, a notebook? I think this part is pretty rough going. These callbacks notebooks, they're not easy to. The callbacks material is not easy, and so that's why we'll spend a little, we'll try to take our time going through it. So I'm going to start with the 05 Annealer notebook. Get ready to share it. Not sharing. There we go. I lost my sharing button. I'm going to go back. Okay, so now I'm going to share the notebook. It's 05 Annealer _JCat. Is that being shared right now? Oh, now, hold it. Now it should be shared. The 05 _Annealer, is that being shared now?
Yes, I can see it.
Thank you, sir. All right. Okay, so this notebook is about flexible learning rate schedules designed using callbacks. And so he's going to explore learning rate schedules, which is a great invention that I think it's Leslie Smith has introduced or pioneered in the last year or so, couple of years or so, and Fast.ai has taken it up and shown that you can get really great increases in performance when you schedule the learning rates in a certain way, which we'll explore a little bit later in this notebook. So first thing is just set up. We're preparing to implement the learning rate schedule, so I'm just going to come through these. Import all the code from the previous notebooks. Remember, that's how we set up this thing. Every notebook has, or at least most of the notebooks, has things that they export into a special little file that is placed in the EXP subdirectory, and that has all these objects and so on that were built up in the previous part of the class. And then we want access to all of those objects, classes, functions, and so on. And so the first thing we do is we grab that and import it. All right, then we grab the data set that we've been working with, the MNIST data set. Then we package the data set up into a data bunch object, as we've seen before. Then we create and export a function that returns a learner object as a container for the model. Remember, the learner object has, it contains the model, the optimizer, the loss function, and the data. So it's just a really nice way to package up everything and get it ready to do a training loop. So, and we went through that last time, I think. So this is just a function, right? So now we're going to actually instantiate a learner object by calling that function, and we're going to run it by running the runner class with the average stats callback that we built last time. And the average stats callback is going to give us the accuracy as an output. And then we're just going to, so we build this, we create this runner, and then we run the training loop. This is how it's done. And the nice thing about this data set is that it goes really quickly. So what we're seeing here on the left is the loss function, and on the right is the accuracy. So you see that the accuracy, so we're looking at the training accuracy and then the validation accuracy. And you can see that in the three epochs, the loss function decreases nicely and the accuracy increases. And at the end, the training accuracy is comparable to the validation accuracy, so that means that you're not overfitting. So this is all good news. So we already know this because we've already run this before. So now we can do the same thing again, but change the learning rate. I think, let's go back and remember what the learning rate was. I think it was, we don't even see it because it was a default. There was a default. And I think it was, the default was 0.5. So now we're going to run it with 0.3, the same thing. And we get slightly poorer results. So maybe 0.5 was a better learning rate. Anyway, that's fine. Now we're going to take we're going to use this, let's see. We're going to export a partial get model function that takes only the learning rate as an input. So it gives, it already provides this partial function in Python. It says, take this function and give me a partial version of that function with all the inputs in place, and it only needs the learning rate as an input. So that's what I've written here, and it's done that. Okay. And now we're going to start building learning rate schedules. So here's the linear schedule. It takes a start and an endpoint, and this marker called position, POS, that marks where you are in the schedule, and it returns a partial version of the schedule with, let's see, okay, this underscore inner is a function that takes as an input the start, the end, and the position, and the position is a fraction. Let's see, no, the position is a fraction between 0 and 1. And so this little function underscore inner returns the actual position in the schedule. Start plus fraction times end minus start. That gives you the position between start and end. It tells you where you are between start and end. And so now we're going to return a partial function that takes inner as its input. It's a partial version of inner that has start and end as its inputs. And then he does this. There's a refactor going on with this decorator, and I think I want to talk about a decorator later. I wanted to say some words here, but I didn't get around to it. Anyway, so it creates this annealer function that takes this inner function as this inner underscore inner as an input and returns a partial version of it, just like we had up here. Oh, actually, it returns a partial version of f with start and end, and then we return that function. So, you know, I'm going to have to think more about this and explain it next time. But for now, we'll just use it. All right. So now this function that we just built, let's see, which is called f. When we give it the schedulin as an input, and so we tell it we want to build a schedule between 1 and 2, and give me the point that's 1, and then f of 0.3 says give me the point that's 0.3 of the way between 1 and 2, and it does that. It gives you the point 1.3. So we'll explain this a little bit later. I meant to do that in this thing, but I didn't. So we'll explain it later. But the point is, we've built ourselves a function that, when given a start point and an end point, then you give it an input, and it'll output the point that is this fraction of the way from the start to the end. So you can see that makes sense as a linear schedule. All right, then he shows you can build other schedulers, cosine schedule, a constant schedule, and an exponential schedule, which we'll see the use for later. And then he also adds a point. He adds an endim property to the tensor class, so that tensors can be plotted. It turns out that when they tried to plot tensors, they found that the matplotlib plot functions wouldn't work because they wouldn't wouldn't because the tensor class didn't have an ending property that tells you how many dimensions it has. So as an example of the flexibility of PyTorch and Python, this is all it takes to refactor the tensor class so that it has an ending property. And now when you have a tensor, it will automatically have an ending property, and it will be plottable. So that's what he said down here. So then with that, he says, let's visualize those learning rate schedules that we built up here, the cosine, the exponential, and the constant. We can plot them. And here's how that looks. Oops, I forgot to run this one. And there it is. So there's the constant schedule. There's the linear schedule that we originally built. Here is the cosine schedule, and here is the exponential schedule. And I just refactored this a little bit to put labels on the plot and so on, so you can see it. It's not a big refactoring, but just to make it nicer. You can see that you're plotting the learning rate versus the iteration number, and the colors are coded, telling which ones you're looking at. Okay, so the next part he does is he says, okay, now we've built these building blocks, these schedules that we can work with. Now, what if we want to do? What if we want to combine schedules? What if we want to have one part of the schedule being, let's say we want the first 2/3 of the schedule to be a cosine schedule, and then the last schedule to be last 1/3 of the schedule to be an exponential schedule. Well, how can we do that? Well, that's what he does next. So this section I call it constructing piecewise schedules by combining schedulers. We have this function that does that, and so this is a function. I don't think I'll get into the weeds of discussing it, but basically what it does is it first the input is the fraction. So if you want to build a schedule that is 2/3 of one schedule and 1/3 of another schedule, then fracs would be 2/3, 1/3. It would be a I think whether it's a list or a tuple, but the point is that the fractional parts have to add to 1. So that's the first thing he does is he checks that. So he checks that when you sum all the fractions, first of all, that they're greater than 0, that each fraction is greater than 0, because fractions, if you're talking about a fractional part of the schedule, it has to be a positive number. And also the sum of the fractions has to be equal to 1. You can understand that if you check only this first one, you won't catch all the errors, because a bunch of numbers can sum to 1, but some of them can be negative, and then they would still sum to 1, but they wouldn't be valid as fractional schedule pieces. All right. So here's that function. So the example is use 30% of the schedule to go from 0.3 to 0.6 following a cosine schedule, and then the last 70% of the schedule go from 0.6 to 0.2, still following the cosine. Now, notice that we're building a piecewise schedule that's piecewise continuous, because the end of the first part of the schedule is the first, the learning rate from the end of the first part of the schedule matches the learning rate from the beginning of the second part of the schedule. So the schedule is piecewise continuous. You wouldn't want something that has jumps in it. All right, so this is how you use that function combined sched to build this simple combined schedule. You give it the piecewise fractions that you want. The first schedule will be 0.3 of a cosine, and the last 0.7 is going to be also a cosine. And so, and these are the corresponding schedules. The cosine scheduler for the first part goes from 0.3 to 0.6, and the cosine scheduler for the second part goes from 0.6 to 0.2. So now you plot it. Because I didn't execute this cell. There it is. And there it is. And I just want to show how beautiful this code is, because if you want to change it, let's suppose you now say, oh, I want to change it. I want to be 0.1 of the first cosine schedule, and then I want to be 0.9 of the second cosine schedule. And then I also want the schedule to change. I want the the initial schedule to go from point 1 up to point 7, and then I want the second piece of the schedule to go from point 7 down to point 1. I want it to be a piecewise continuous schedule again, right? So that the last part of the learning rate for the first part of the schedule has to match the first part of the learning rate for the second part of the schedule. Let me show you for a second what happens if it does it. So suppose I don't pay attention to that piecewise continuous thing. Now let me show you what the schedule looks like. And so you get this jump, and you don't really like that. Actually, let me make it more obvious. I'll change the fractions and what happened? It says assertion error. Oh,
Does the fractions have to add up to 1?
That's right. Exactly. That's the assertion error. That's the assertion error caught that error.
Oh,
and
okay.
it would do the same. Yeah, right. And it would do the same thing if I did something stupid like this. You know, suppose I put 0.4 suppose I put minus 0.4 as the first part of the schedule, just by being careless, and then I put 1.4. Well, those add up to 1, don't they? But one of them's negative, so it's going to throw an error. And we didn't actually identify which error, but we know what it is. And here it is. It's the place where it checks that well, the sum of the fractions are 1. That works, but the way where it threw the error, I think, is where all of the pieces have to be greater than 0. Anyway, so let me go back, put it the way I wanted, 0.4 and 0.5. Sorry, 0.4 and 0.6. Those add up to 1. So 40% of the schedule is going to be the first thing, and 60% of the schedule, the last 60% of the schedule is going to be the second thing. And let's run it this way and see what happens. And there you see that ugly jump, right? This is what happens when you don't have a piecewise continuous schedule. So you could actually build into this function another assertion to make your schedule piecewise continuous if you wanted to, but we didn't do that. So let's go back to the original schedule. I think he said 0.3 to 0.6, and then 0.6 to 0.2. There we go. And oops, that's not right. A minute. 0.3 to 0.7, and then it was going to go from, I think he had it going from 0.3 to 0.6. These are learning rates that we're specifying now. And then coming down on the downward part, you want to go from a learning rate of 0.6 down to a learning rate of 0.2. I believe that's how we had it originally. So let's run that. And there's that nice looking schedule. And this is what they found in, I guess, Leslie Smith's research, that you need to have a period during which you're training at a high learning rate, slowly training at a high learning rate, and then a longer period where you're training at a lower learning rate. And then you, as things start to converge, you want to decrease the learning rate. So this is kind of some kind of a nice schedule that people have come up with that seems to do a good job for getting models to converge. Okay.
I have a quick question for you.
Yes.
Did you play around with the different types of piecewise schedules for like not just cosine? I guess I'm trying to determine if the upward and downward is necessary for each of those examples.
Oh, okay. So exponential schedules. I think exponential schedules, the way they're defined. Let's go back to the definition of exponential scheduling.
And I lost your screen there too.
Oh, okay.
Maybe
how about now? Is it back now, or?
I'm not seeing it.
I
also lost the screen.
Yeah. Okay. Let me find. Zoom is asking me to join a meeting or sign in. So let me understand this. Let me try to find what it is. Yeah, it's doing some weird stuff. I'm going to try to do what it suggests and sign in. But you guys can still hear me, right? So I must be still in the meeting somehow.
Yeah.
Yeah.
For you.
It's kind of weird.
Yeah, I've lost the Zoom information on my screen. So you know, where it tells you you can share and you can see the participants and all that, I don't see that. Okay, I think what I'm going to do is, now I got a message. There's a problem joining the meeting from the Zoom client. Click join from browser to join the meeting from your browser. So I'm going to do that. So I'm waiting. Am I still in the meeting?
I don't see your screen, but we can hear your voice.
Yes, okay. Yeah, I'm having trouble getting in. So let me go back to that email and just join from the email. See if I can. Join the meetup. Ah, it's giving me a problem. It keeps saying that it can't find the site. Server not found.
Are you on your phone for the audio, or were you?
Well, well, yeah, I'm on my phone right now. So maybe that's what it is. Because I remember, as I said, I have to join the audio by phone, and then the rest of the part of the meeting on my computer, because my computer doesn't like my microphone for some reason. Zoom doesn't like my computer. No, my microphone works perfectly, but Zoom doesn't recognize it. So yeah, so that's what's happening. I'm talking to you over my phone, and I can't join the meeting over my computer, which might mean that I lost network connection on my computer. Let me try something. Get out of. I'm just going to try unconnecting my network and then connecting back. Back in. Meeting again. Okay, is everybody still there?
Yes.
Yeah, I'm still here.
Yeah, I hear you. Okay, I'm going to have to try the nuclear solution. I'm going to have to reboot my computer. And
you don't think it'll kick us out, do you? Since you're the host? It shouldn't.
Well,
right?
My computer has already lost the meeting. So if I reboot my computer, I don't think you guys are going to get kicked out.
Okay.
I hope that's true. All right, let's see what happens. Well, maybe before I reboot my computer, I'll just restart the browser. Maybe that'll be the solution. I'm going to restart the browser. Which means I have to restart all of the notebooks, I think. Oh no, it's not letting me. Oh. I have one more idea. I'm going to try to use my phone as a tether and get network connection that way. Surprising, because my network connection is usually really good. Okay, now I should be connected. So Okay, the nuclear option it is. I'm going to reboot my computer because that didn't work. Great. So give me about 2 or 3 minutes here. Okay. While I'm waiting for the computer to come back up, I was wondering how people are finding these notebooks. Are they really heavy going, or like I know that we have a lot of different people with a lot of different backgrounds here, and some people probably find it very easy, and other people might find it really rough going. So what's been your experience so far? Anyone?
I'm personally trying to challenge myself a bit more to not just follow along and run each of the sections of code, but really try to understand it and maybe do some original creation. But I've not done as well as I would like. But the notebooks are very helpful.
Yeah, that's what I find. I'm also at that point. I want to do something more with the notebooks, but I feel like I should first go through the class and really understand it well, and then after that I'm going to try to do some projects. And I just don't have enough time to do it all at the same time. Okay, the computer's up and it says that it's connected. Now let's just see. Yeah, I now have network connection. So now I got to bring up the notebooks again. Oh, first thing I can do is bring up Zoom. Okay, now Zoom says it's connecting. Oh, now I've got it. Yeah, not. Okay. Wait. Okay, I'm almost there. Into the notebooks. Get into .05 foundation. Oh, 05 Annealer. Sorry. Okay, so I'm back to the notebook. Now I'm going to start sharing it again. Okay, you should be able to see the notebook 05 Annealer. Is that true?
Yep, we can see it. At least
Okay,
I can see it.
Okay, I'm going to execute my way all the way through where I was because I just brought it up. Get back down to where we were. So, okay, so I think we were asking a question. I think Christina was asking a question about the different kind of schedules. And I'm just looking at, there's a cosine schedule, there's a constant schedule, and there's an exponential schedule. And yeah, the exponential schedule has the possibility to have positive and negative. Oh, no, it doesn't. It doesn't have a possibility to have negative schedules, sorry, decreasing schedules. It only does decreasing schedules, as you can see from the form of the exponential. The exponential is this fraction end over start to the power of position. Oh, end over start is always going to be bigger than 1, and the position is going to be between 0 and 1. So the result is always going to be bigger than 1. So this only gives, oh, and as position increases, this thing increases. So what I see here is that you only can get an increasing schedule, an exponentially increasing schedule. Let me see if, and I think that's, but I'm a little confused because I thought I saw an exponentially decreasing schedule in the, yeah, exponentially decreasing schedule. So how did that work? How did we get a decreasing schedule when this function looks like it only, oh, of course, because, no, not of course. End over start is always bigger than 1, right? Because end is always larger than start. And when you take a number bigger than 1 and express it to a power that's less than 1, then you're taking the roots of it. So like if position, if POS is 0.5, then you're taking the square root. And if POS is 1, then you're just taking the number itself. And the square root of a number is less than the number if the number is bigger than 1. So I'm having trouble convincing myself that this makes sense, that the schedule should be decreasing. Anyway, that's worth playing with. I don't want to stop here. But yeah, I think you have the right idea, Christina, that you want to play with these notebooks and try to see how they work and modify them and so on as you go along. Okay, so the next thing he does is he repeats this thing using callbacks. Repeats this design of the scheduler using callbacks to make it more controllable. So the first thing he does is he builds this recorder callback, which has this function, let's see, if not, okay, it returns if you're not in the training phase. Otherwise, it, let's see, I guess it appends a learning rate and the loss. So it returns a learning rate. It can calculate, it gives you the learning rate and the loss that's associated with that part, with that learning rate. Then it has a method to plot the learning rates, and it has a method to plot the losses. And then, let's see, then he's got this thing called param scheduler. It's another callback. I haven't understood what this underscore order parameter does. Does anybody know what that does? I've seen it, he's got this in some of his callbacks. Sometimes he sets it to 0 and sometimes he sets it to 1. And I'm not really sure what the function of that parameter is.
By default, the callback has a parameter for 0. So that kind of tells you if you have a bunch of callbacks, which order do you want to run them in?
Oh, okay. So then this one has order 1. This one doesn't have an order.
So that means, but yeah, it's inheriting from the class callback, and callback already has an attribute underscore order is equal to 0, so it'll inherit that. So recorder
okay.
already.
So okay, I see. Callback itself, you're saying, already has an underscore order equal to 0, the way it was when it was defined, right? And you're saying that this class, since this class inherits from callback, that means that recorder has init equals 0. And here, param scheduler also inherits from callback, but now we're overriding the order parameter and writing it to be 1. Okay, that's understandable.
Right.
Thank you. Okay, so so now he's using this these new classes that he defined. He creates a list of the callbacks that we want to use, and one of them is recorder, one of them is a partial version of average stats. We just want the accuracy, and another one is a partial version of param scheduler, where the learning rate and the schedule are the only inputs are learning rate and schedule. So let's see what that does, or let's verify that it works. Make a learner and a runner, and then run the schedule, just like we did before. And then plot the schedule that we got, and it is the same schedule that we think we have. And then we plot the loss function, and it looks like that. All right, so the last thing we do is export all this stuff for use in the next notebook. And the next notebook is O5A Foundations. So let's have a look at that one. All right, so here he's doing an extended riff on callbacks, and I've kind of done some minor editing, just sort of organizing the notebook so that as you scroll through it, you can see what he's doing. So first he talks about the fact that you can use callbacks as GUI events, and people who program in JavaScript or whatever, some of the languages where you actually build GUI interfaces if you have experience in that, you've probably seen callbacks used that way, where you define a widget or a button or something and then you use it. We'll go through that in a bit. Creating your own callback. Here's an example where you can create your own callback. Here's where he explains a little bit more about lambda functions and partial functions, which is good because we've already used partial functions and it might be confusing to some people. We'll go through that. And callbacks as callable classes. So, the way we've defined callbacks is that a callback is basically a function that you can insert somewhere in your code to accomplish some desired task. And we've called them as functions, but you can also use them as callable classes. So and he's done that. They've done a lot with callbacks in Fast.ai, and there's more to come in Fast.ai version 2, which I don't know when the release date is, but a lot of the stuff we're learning here is going to be incorporated into Fast.ai version 2. And then he shows how you can modify the behavior of a function using a callback class. And then there are some examples. And then he talks about dunder thingies. It's kind of a cool name. And then he has an extended riff on variance and covariance and correlation. We've got 15 minutes. I hope I can make it through this notebook, but I don't think so. But we'll give it a try. And then the Softmax discussion we've already done. And then he talks a little bit about browsing source code and about how some editors you need to have a good editor. He says you need to choose yourself a good editor so that you can that will have a lot of features that will help you when you create code. And he demonstrates these things in Vim, which is his editor of choice. But there are other editors that work that have these nice features in them. One is Emacs, one is Visual Studio, one is Sublime, and the one that I've been using, I'm not sure if it's as good as these, but I've been using this editor called Atom, A-T-O-M. I'm on Windows, and this is a public domain editor. All right, let's go back and see how far we can get here. Callbacks as GUI events. So here he's importing this library that helps you create widgets. Then he's creating this widget with a label called click me. And then you define a function to associate with this widget. And the function is just going to be print hi, but you could make it do anything you want, really. This is just as a demonstrator to get it started. So then you define what you want to happen when the widget is clicked. And what you want to happen is you want it to execute this function f. So now the widget will know what to do. Now let's create the widget, and there it is. It creates the widget using this thing, and the widget says click me, and now we click the widget, and indeed, lo and behold, it executes the function that we told it to execute, and this text appears hi. And if you want to modify it, you can say, you can say something like, it's cold outside. What's going on here? Can I do that? I'm going to be grammatically incorrect. So what if I modified my function, and then I create the widget again, and click me, and now when I click it, it says it's cold outside because I've modified the behavior of the widget just using this function. So that's pretty cool. Then he talks about this really fancy widgety thing, but let's skip it for now. He didn't create this. He just says this is an example of what you can do with widgets, and it's kind of cool, but we'll skip it. Okay, creating your own callback. So now we're gonna get the sleep timer so that we can put delays in a function. That's what the sleep timer does. So here's we're gonna do a calculation, but we're gonna delay. Okay, this calculation is just gonna be to compute all the squares from 1 to 5 and sum them. That's what this function is doing. But we've put a delay in there. And I just put this time it function to show us what it's going to do. It's going to execute this a few times, and then it's going to take the average execution time. So we'll sit back and wait a little bit while it's executing. It won't take that long. And it's a slow calculation because it's being delayed. I just put this time it magic thing on it because I wanted to see how much delay you're getting, because it doesn't tell you this. It doesn't tell you what these units are. When you say delay equals 1, how much delay are you getting? And you can see that here. It did 7 runs, and it finds that the delay you got, the time that it took to execute was 5 seconds. And since the loop has a length of 5, that means that it took 1 second for each delay. Because inside of each, after you calculate each square, you delay by 1 unit. And I was trying to figure out how long the delay unit was, and I find that it's about a second. So when you say delay equals 1, that means delay 1 second. All right. So now he has this new function that says, if there's a callback function, it's a callback now. And if there's a callback function, execute it before returning the result. So you can see what it does. It loops, it does the loop, and after each calculation, it executes this callback. After it calculates each square, it delays 1 second, and then it executes this callback. And you can see the callback is being passed into the function. Its default value is none. So when you call slow calculation, you give it a callback, and then it will execute this callback each time it calculates a square. So let's define this function, show progress, and then we'll pass that function into slow calculation as the callback. So show progress is the callback that's being passed into our function. Now let's just show you something here. This is the beauty of using these keyword arguments, because what if I did this? What if I call slow calculation without an argument? So what this tells it is that the default, when you define the function, it says the default value of the callback is none, and the default value of the delay is 1 second. So I don't have to provide any inputs, and it already knows what to do. So I'm going to do slow calculation without giving it any inputs and see what happens. and we see that it ends up doing exactly what its original function was, which is to compute the sum of the squares from 1 to 5. So it works. The neat thing about this keyword argument is that it controls the behavior of the function, and so that it makes this function flexible. You can either give it a callback as an input, or you can not, and it'll still know what to do. So now let's define this callback and give it the callback as an input, and see what it does, see what its behavior is. And so it tells you, it does exactly what you asked it to do. The callback tells it to print this line. It says, awesome, we finished epoch number, and then it takes the epoch as an argument. So it's done what we were told it to. Now it says how to do this. Another approach is to pass an inline function that does the same thing as show progress. So now we just do slow count. In other words, instead of having to define the callback beforehand, we define the callback inline here. And do that, and execute it, and you see it's doing the right thing. So we've used the lambda function. And it says, print awesome, we finished epoch blah, and so it just goes through, it iterates through the epochs and prints the epoch. Now it says, okay, let's modify this callback, the callback we did before, to replace awesome with something else. So we do that. And so here we've taken slow progress and make a small modification. We can give it whatever exclamation we want. And let's try that. So now we've replaced the awesome with okay, I guess. Okay, so fine. Now he's being more sophisticated. He says, given an exclamation string as an input, return an inline function that does the same thing as show progress. So now we can pass the function make show progress of nice into slow calculation. And so now we can do everything on one line. We can control the function from this line, because if we want to change it, we can just modify this exclamation string here. Instead of nice, we could put terrible, we finished epoch 1, or whatever you want. Okay, so now he has another revision of make show progress, returns a lambda function. And he calls this a closure. For some reason, that's the technical term for it in Python. So he defines this underscore inner function, print exclamation, we finished epoch, and then return that, he returned that function. This underscore is generally understood to be private. That is, it's only inside the function, and you don't generally share these outside the function. So instead of, so he just passes this out, so that if somebody says blah equals make show progress, that blah will get this function as it will be this function. So here it goes again. Let's show how that works. Still below, I could do this. And then I could do this, slow calculation of blah, and then I would get the same result. Because blah is now a function that is being passed into slow calculation. Oops, I have to define blah first. Then I can run it. And then it does that. And then, of course, you could do the whole thing on one line. She does here. Oh, and then this next thing is, well, I think I just did it. This demonstration here where you take F2 equals make show progress of terrific, and then slow calculation of F2. That's the same thing I did with blah. Okay. Try this again. This just shows how plastic and modifiable these functions are, the way he's coding. So this is this is the software engineering thing where you make progressively nicer features into your functions and make them do what you want. All right, I'm really running out of time, and I feel bad, and I wanted to get through all this. I've written I've put enough comments and breadcrumbs in here so that you should be able to, when you go through them, you should be able to see exactly what's going on and hopefully understand everything. I put a lot of explanations in here that should help you to understand everything. And unfortunately, there's just not enough time to go through. I have two more. There's actually one more that I have to go through. That's just 05B, or that belongs to this lesson. 05B, early stopping. And we won't have time to get through that. But again, I would urge you to go over this on your own time and just run through them and try to understand what's going on. And again, if you have questions, please post them on the forum, or on the forum or on our Slack channel. I'll be happy to go over them with you. Anyway, are there any questions at this point? I need to end this meeting pretty soon so people can head over to the CS224 meeting. So are there any questions that people have at this point, or comments?
No immediate questions, but thank you for hosting this meeting.
Okay, thanks, Philip.
Yeah.
Thanks. All right, everybody, have a good week, and we'll see you next week. We'll either finish chapter 10, or maybe we'll have to take maybe we'll have to take it in 3 bites. We'll see how that goes. I don't want to rush through it too much. So, all right, take care now. Bye.
A quick question, if you have a second.
Yes.
In a software engineering discussion, you were suggesting that it's a good idea to put the keywords whenever you call a method or function. Are there some good IDEs or editors that could be used for that give suggestions on the keywords so that I don't have to look at the API all the time? Thank you.
Oh, I don't know. I'm not very sophisticated as far as choosing editors goes. I just chose a simple one called Atom, and I don't know if it has that function. But yeah, when you use a keyword, you still don't have complete knowledge. It depends on how well the people named the keyword. If the keyword has a very descriptive name, you can pretty much understand what it's doing, but that's not always going to be the case. But at least it's better than just dumping the number in as a number, because that's completely ununderstandable. If somebody says an input is 3 or an input is false, I have no idea what that 3 or false means, whereas if they give it a descriptive name, I can at least get an idea of what it's doing. But you're right, to really understand what that input is doing, you have to look at the function, look at the help function, the API of the function. So I don't know a way around that. Maybe somebody else does.
Is the question, are you talking about when you're typing the function name, do you want to know what parameters to enter? If that is the question, then in Jupyter Notebook, you can just hit Shift Tab, and Shift Tab will basically show up. Yeah, so if you jump into any of your functions and if you hit Shift Tab, then it'll show up all the parameter lists.
Right.
And it's kind of the same.
Is
that what you're asking?
Yes, but if you're not working from within Jupyter, you're working in a text editor or some other integrated development environment.
I'm not sure about text editor, but like, for example, if you're typing stuff in Visual Studio, then I think like control and space.
Microsoft,
control
right?
Space kind of. Yes, the Visual Studio one, control space kind of shows you the parameter list. I mean, the keyword arguments, all the arguments that go on. Usually most of them do, other than if it's a really simplistic editor, I guess. I don't know about that. Even Python, for that matter, in general, the Shift Tab stuff works.
Yeah, so let's just try that for a sec here. I got this slow calculation function. I'm going to do Shift Tab in Jupyter. No, it's not doing anything.
I don't see the screen though.
Oh, I'm sorry. I'll share it again. I stopped sharing it. Let's see. This is the one. Are you seeing it now?
Nope.
Share. There it is. Now you should be seeing it, right?
Yes. Yes.
Okay, so now I've got slow calculation, and I do Shift Tab. Oh, there it is.
There you go. Yeah,
No
pretty much can put your question. You can kind of put your cursor within the those open and close brackets. So if you actually jump into like the runner or any of those functions, you can really see all the lists of arguments that are passed in and so many of the default arguments.
Okay, let's go up to one of these. Maybe on one of the.
Yeah, exactly. If you move over to the previous, yes, yeah.
Yeah, over here. So here's there's a runner class.
Yeah, let's go. Create learner. The create learner one is a good one to look at.
Oh, create learning. Okay, let's see.
Yeah, right there. I think you already had it up here.
Oh, this one here. This one here. This one here. Okay. So let's just do Shift Tab and see what it shows up.
No, I was kind of scroll up. I think you missed the create learner function.
Oh, sorry. Create learner. Get model function.
I think it's towards the right.
There it is.
Yeah.
Right there. Okay. So Shift Tab. It says model function loss data. It says
hang on.
Give you a
that is the one where you. That's kind of where you've defined it. So if you go to the next cell 6.
Okay. Right there.
And yeah.
And then create learner.
And inside
right
create.
there. Okay.
Yeah. In this case, yeah, you've already written out all the keyword arguments. But if you hadn't and you were, for example, writing create learner, open brackets, and then if you hit Shift Tab, kind of tells you what the parameter list is.
Okay, let's try that one then. Insert cell above, create learner. That. So if I just do that, and then I just click there, Shift Tab.
Put your cursor within the
yeah.
There you go.
Yeah, it shows. That's good. So it tells you all the inputs that it expects. And then if you had a doc string inside.
Right.
Yeah,
if you had a doc string and you had
it would show you.
Sorry, go ahead.
So, yeah. Thank you for that. I didn't know about the Shift Tab, or at least I knew about it, but I didn't remember about it.
And the other tip is that, can you see the pop-up that shows there's a upwards arrow at the end?
Yes, like that.
Yeah, so usually if you have documentation, if you click that, the whole thing shows up over there. So this is kind of the question mark function that you have. So yeah, it's kind of really helpful when you're typing.
It does the same thing as the question mark question mark.
Right.
So like that. Well,
basically,
that's because
it's already there down there.
That's okay. Okay, well, thank you. That's really useful. I'll remember that Shift Tab for the future.
Yep.
Okay, any other questions? Okay, well, I'll let everybody go. Since the next meeting is starting. I'll stay around a little bit if somebody who's not taking 224 wants to ask some questions.
I was thinking, Joseph, sometime we should kind of cover the debugging process.
Yes, I was just thinking about that this morning because somebody asked a question last week, and I think it would be really useful to see how that works. So I'll consider making an example of that for next. I'm going to make a note right now.
Yeah, I was actually going through with the callbacks function with that, and that makes so much more sense. Because there's a function calling a function calling a function.
Yeah, this is really dense material, I must say, and at least for me it is. And
yes, it is.
And I think it's important to not rush through it so that we will be able to keep up with him, because it only gets worse, because now that he's built all this cool stuff, the next thing he's going to do is use it all and stuff, and so we'll get behind very quickly if we don't keep up with if we don't really get the complete lesson. So yeah.
And if you're using Fast.ai v1, the runner and all that is not implemented. So you need to go back and kind of look at the small nuances and differences that is implemented in the learner.
Right, and then soon enough, Fast.ai version 2 is going to be implemented. Then it's going to have all this cool stuff in it. And if we study it now, then we're going to know it ahead of time, and we won't be bowled over when the new version comes out. Does anybody know what the schedule? Does anybody know what the schedule for Fast.ai version 2 release is? They're working on it really hard, I know. And then another question is, at the beginning of the class, Jeremy mentioned that he wants to do some work on sound processing. And I wonder, and he said he was going to actually create a couple of extra lessons. And I don't know if, does anybody know where that's gone?
Yeah, I didn't see any audio formatting stuff out there.
I know that somebody else has gone off. There's a group of people that have gone off and built their own audio processing code. And maybe Jeremy's just going to figure that they did a good job on that, and that's good enough, because they did there's a forum topic that I've noticed. I haven't really read a lot. I haven't really spent a lot of time, but they've done a lot of work on audio processing. And so they might have built
the Fast.ai forum?
Yes. Yes.
Oh, okay.
I forget the names of the people involved, but they're doing a lot of work on that. And that's an interesting topic to me. Okay, finally, there's a, let's see, Michael announced on the Slack channel that there's going to be a new class starting on September 2nd. It's called machinelearning.ai. That's the website of it. And it looks like a really nice course, mostly in the classical non-deep learning, I think, mostly about the things that are used on the Kaggle, the methods that are used on Kaggle, which are mainly gradient boosting. So this course goes through from the beginning and takes you all the way through gradient boosting, and I believe they even participate in a Kaggle competition as part of the class, and that sounds like a really exciting class to take if you have the time. And on the Slack channel, watch on the Slack channel, because I think they're organizing, and I think Sanyam said he would organize that class. It's starting on September 2nd, and again, it's called machinelearning.ai. So check it out and see if you're interested, and if you have time to do it. It'd be worthwhile. All right. Are there any other questions or comments that people want to say? All right. Well, thank you for your attention, and I'll see you again next week.